Hello and good morning, everyone. Thank you for joining our webinar. We will be starting in a couple of minutes, just waiting for more people to join in. But I just wanted to get your visual verification. If you can see or hear me, just let us know in the chat box on the right. Thank you. Perfect. Thank you very much. There's still a couple of minutes, so if you guys want to run to get your coffee, feel free. We'll be here. I know we're at the hour. We're just gonna wait another 1 or 2 minutes and then we'll go ahead and get started. All right, let's get our session going. Hello, everyone. Thank you for joining, whether you're from APAC, Europe, Middle East. Welcome to our session. Thanks for joining our webinar, where we will introduce to you our newest collaborative effort between Genetec and Bosch around airside video solutions. But before we begin, I wanted to launch a poll here just to get a better idea of some of the challenges that you typically face at your airport environment, especially in the apron area. So if we can get your feedback for that, that would be awesome. Perfect. Thank you for your feedback. All right. So before we begin, I wanted to quickly introduce to you our speakers today. My name is Cheryl Stewart, and I'm the Industry and Applications Marketing Analyst here in Genetec. Joining me today are three gentlemen, and one in the chat, as you probably saw if you asked a question. My colleague, the first one is my colleague Nicola, who's our Software Development Manager for Critical Infrastructure in Genetec. Next, we have Martin Wings, who's the Airport Practice Lead in Bosch, and Constant Rutten, who is the Product Manager in Bosch. Welcome, guys.
Thank you, Cheryl. Welcome as well.
Hello,
Thanks.
welcome.
So, I also wanted to remind you that if you have any questions at all during the session, feel free to ask them in the question dialog box, as you can see here on the screen. Our moderators will be actively answering them throughout the session, and we'll also have a Q&A session after if there's any other questions that we haven't addressed. And then lastly, I also wanted to let you know that this session will be recorded, so we will be sharing the recording as well as the presentations after. And so with that said, let's get started. So Genetec and Bosch, we've been working together for quite a while now, and we've collaborated on multiple different types of solutions, as you can see from this extensive list here, from video analytics to cloud-based monitoring solutions to access control systems, fire alarm systems, etc. And today we're here to add one more to that list, and this is specifically for airports. But before we go in further, I wanted to, help you better understand why we actually decided on our collaboration to produce this airside solution in the first place. So we actually saw an opportunity in the market to consume video surveillance beyond the traditional indoor setting in airports. And then by engaging with our customers, we saw that there was an increase in terms of the need to have an automated video surveillance system in the apron area, as well to increase the efficiency of operations and safety and security in these specific areas. And so we thought, why not us, right? Genetec and Bosch, we both have extensive experiences with airport customers. We both have about 300 airport customers that we serve globally. And the solutions and products that we both have are definitely able to meet our airport's new needs. So, Bosch has a portfolio of a lot of different sensors and cameras that are exactly the right fit for the airport environment. And Genetec, on the other hand, we have a portfolio of airport-specific modules that were actually developed to add on to our security center platform to meet airport-specific needs. So, with these building blocks that we have to lay the foundation, paired with also our ability to combine our solution offerings through our seamless integration of cameras as well as software, we're able to create a collaborative solution that provides true value to airports that really stands out from the industry. And, that is essentially what we really wanted to share with you today. So now to take you through quickly our agenda today, we will be covering 4 main areas where our solution will provide value. The first that we will cover in our solution is around aircraft traffic video surveillance. Next, we will discuss on how you can have a 360-degree perimeter protection for both ground intrusions and air intrusions like drones. Then we will go into vehicle speed detection in the apron area. And then lastly, we'll talk about how we can help enhance your airport apron monitoring capabilities. So now that I've given you some background, Martin, would you please start us off with the first section on aircraft traffic video surveillance? Over to you.
Yes, thank you, Cheryl. Of course, I would like to do that. So this is the first use case which we would like to discuss with you. So maybe as a background, the use cases which we present here and which we identify are actually coming to Bosch and Genetec through customer contact. So it is something which we have been actively approached for by customers which we have been talking to. And one of the first topics that we would like to discuss is the recording of aircraft tracking on video. So why is that? So we were in discussion with a larger airport, which has, of course, very busy runways. And sometimes it can happen that incidents occur on the runway. And this can lead to major operational disruptions. It can also lead to big safety issues and can even be giving loss of life. And very often it's a process that is only monitored from the tower without any use of additional equipment. Looking at the landing and the departure, this is actually the most dangerous part during the journey of the aircraft. And not having anything here recorded or not having anything here being monitored with additional technology is actually something which is not common practice, but opens new opportunities for the future. So as we can see on the next slide, starting with recording of landing and departures actually brings a lot of benefits to an airport. So with that, also technology which is there already for a while, actually, it is now taking its first entrance or introduction into the airside area. So imagine an aircraft would now belly flop on the runway, and afterwards this needs to be investigated. Of course, you want to understand why did this happen. Just relying on what the operator saw from the control tower is not really helping you to do a thorough investigation. So it actually makes very much sense that you make a recording of the landing and the departure. This allows you to analyze afterwards in hindsight to improve the safety of the landing and the departure, and also to have an evidence on what actually happened. Also, in case of a damaging runway or damaged assets, that also very often comes with a question for liability. So who is now liable for damage that is being created? Also there, if there is a recorded proof, that is also an evidence which can serve in such cases. Not only that, it's not only in hindsight where we can use video technology, it's also actually during live operation. So verifying whether a landing gear is already out is something which an operator in poor visibility with binoculars needs to do, but it's difficult up to a certain extent. If you have a video technology, very often you can verify that already much earlier and then inform a pilot if the landing gear is not down, as also with poor visibility, a camera can simply see better than human eye. Having said that, also if an aircraft is landing as a heavy gear, so loaded heavy, and is damaging the runway, also this is something which you would like to analyze, see whether there was any FOD being created, and also have something which you can confront the airline with, that they are landing too heavy on the runway. So this is the background of the use case, and there is quite some technology which comes together to enable that. Maybe Sherwal, you could walk us through how this system works.
Sure thing. Thanks, Martin. So how do we actually go about resolving this issue that airports were facing? Well, we came up with a solution to track these aircrafts, capture them on camera, and then display it on the security video feed for monitoring. Our new apron movement tracking module, also known as AMT in Genetec, actually allowed us to track the location of aircrafts. So whether it's on the ground or in the air, we're then able to provide the location coordinates to the Bosch MIG cameras to follow and capture the aircraft footages. And then finally, all within our unified platform security center, we're able to display and store these footages, especially when it comes to incident management when needed. So we actually initially developed the AMT module. When we first developed it, we had in mind to provide the operators with a better visibility of the movement of aircrafts in their apron area. And we did that by leveraging the information of the aircraft position obtained from the ADSB, so the Automatic Dependent Surveillance Broadcast. And we ingested that information directly into Security Center to showcase it through a map for better visualization. So here's just a quick look at how the AMT module looks like in Security Center. So your security operator can essentially have a bird's eye view of all the aircraft movements in real time with the flight number attached. And this can actually be particularly useful during low visibility times, or it can be used for communication between different teams on aircraft locations. Now, for those of you who aren't too familiar with the ADSB protocol, how it works is that the aircraft actually receives their position via the satellite navigation through a transponder that all of these aircrafts are equipped with. They then broadcast their position to other aircrafts or also, ground stations that are equipped to receive this information. And to mention here, the AMT module that we have is able to do exactly that. And also, ground vehicles that are equipped with this ADSB transponder, we can also showcase that on our AMT module for monitoring. And I wanted to highlight, as of right now, we don't actually know any other VMS or security platform that's able to connect to the ADSB and provide this information directly in their system. So what we offer here is really quite unique. So in terms of the solution process workflow, in order to meet the needs of airports in terms of tracking aircrafts with video, we adapted the AMT module and collaborated with Bosch to produce this joint solution for this scenario specifically. So as a step one, as I explained, aircrafts, they receive their location data from the satellite navigation. Then step two, the AMT module fetches the aircraft location data and shares it within the Genetec Security Center platform. And because of our unification ability, the sharing of information between different modules and applications are seamless. And so this allows Security Center to easily provide the location data to Omnitask, our video management system that controls the cameras that are required to track the aircraft. And now, with that said, this is all made possible by also the smooth integration of the Bosch MIG cameras to Omnicast, allowing for, the high quality capture of the scene. And then finally, all of these footages, they're stored and showcased on our security desk, which is our security system interface for the best visualization for your security operators. So essentially, with this solution, we're able to address the gap that Martin mentioned earlier for airports in terms of having this recorded video evidence of landings, takeoffs, and taxis of the aircraft to improve the airport's overall, safety, liability, and operations, that three categories that he mentioned. So I'm sure you're excited to see it now in action. I will hand you over to Nicola to kind of show you how that looks like in Security Center. Nico, I will hand the screen over to you.
Yeah, thank you, Cheryl. Yeah. Or maybe you can share the video.
Oh yeah.
Yeah.
My bad. I believe you can see my screen again, right?
All right.
Thank you.
So I'm going to explain the setup first, what we've done in order to create this representation of takeoff and landing. So what you see on the screen is a recording of a takeoff and a landing. And what we've done, we created zones on the map that basically record when there is a detection of a plane arriving or leaving the airport. So we have zones surrounding the runway and a zone also to detect the path where the plane is arriving or departing. And when a plane enters that zone or leaves that zone, we are able to automate the recording of the camera. So what you see here is a takeoff. So as you can see, we can track the plane leaving the airport. And on the right, that's the same scenario, but this time it's a landing, and we can start to track the plane when the plane is detected in the arrival path, and then we will be able to stop the recording when the plane leaves the taxiway zone, basically. So we will be able to track another plane arriving at the airport. So this was done by putting a mic on the roof of the Genetec office, as some of you might know, is close to the Montreal airport. And we just received the ADS-B data from an antenna, and we were able to automate the mic and record those planes. Back to you, Cheryl.
Thanks, Nico. All right, that was really cool that we're able to do that, but there's really also many parts to being able to successfully capture and track these aircrafts, and the camera quality, for one, is definitely among the most important. So before we head over to the next section, I'd like to hand you over to Constant to take us through some of the specifics of the Bosch camera that allows us to use it in this types of scenario. Constant?
Thank you, Cheryl. Yes, well, among the most important things that the camera must be able to do in this type of application, the tracking application, is that tracking needs to be very smooth. And of course, as airports are a full day operation, the camera needs to be able to do that continuously 24/7 hours and for years on end. And you also need a very good image quality, of course, in all kind of daylight and nighttime lighting situations, and a good focus tracking because of the high speeds with which these vehicles or these aircrafts are moving. And the MIG camera is for the very reason. That very reason is the favorite camera of integrators building this type of tracking applications, because it has very smooth tracking. It has a very robust mechanical gear with low backlash, and everything is set to really track airplanes in a good way. Back to you, Cheryl.
Thank you, Constant. All right, so now we're on to our second section on perimeter protection. Martin, I'll hand it over to you to start us off.
Okay, thank you, Cheryl. So as we can see on the next slide, yeah, we all know airports, it's a big challenge to secure the perimeter fence. If it's a crucial area, if an object crosses the perimeter fence, you do not only have an intrusion, but you also have a safety hazard. If a person would be able to reach a runway, you might need to shut down the whole airport. So this is a big concern. However, fence lines at larger airports, so we have equipped airports with a smart system to monitor the fence line, and fence lines go up to 35, 40 kilometers. So it's a huge task. And since it's so highly distributed, and since it's such a long fence line, you need a good strategy, because if you just have a control room and you have operators watching endless video, hoping to find somebody who's now climbing the fence along a 35-kilometer fence line, that is a strategy where you are probably very reactive. you will only find it out once the incident already happened. The alternative to patrol the fence is also something which is not a constant monitoring. It's expensive, it's labor intensive, and it's not securing your fence in the most optimal way. So there is, however, technology available which can help you with that. So if we move to the next slide, I will tell something about this in a minute. Looking at perimeter protection, so you have a long fence line to monitor. Actually, there is a bit of a change now in the intrusion pattern. It's not only objects over ground which are entering the air site anymore. It can also be objects that are coming through air. And actually, considering that we already have an infrastructure in place which is monitoring the fence line, it would actually also make sense to leverage the same infrastructure to also monitor intrusions which are coming through air, because we already have a distributed system along the fence. Because one of the biggest challenges when you need to deal with drones is the fact that the air site is so immense. And if you only monitor drones from a central location, you're easily facing large distances which you need to cover from a central location. While if you leverage the already distributed system on the fence line, you are actually very effectively challenging or managing these large distances in an effective way. Yeah. So maybe Cheryl, you can show a bit how Genetec and Bosch combine this solution for the control room.
Sure thing. So based on the scenario that Martin mentioned, we wanted to create a solution that will allow us to easily detect, track, and also manage these different intrusions and threats, whether they are on the ground or in the air like drones. So we joined forces and brought both of our capabilities together to tackle the scenario. So this started with the Genetec Restricted Security Area Surveillance Module, also known as RSA, that manages, the different intrusion detection sensors in Security Center. So for those of you who aren't familiar with RSA, what it is it's a 360-degree perimeter intrusion detection and tracking management system that actually brings together traditionally standalone intrusion detection systems under a single unified platform. So how does our solution process work? Well, first, the sensor managed by RSA, as you can see in the workflow example here, whether it's a fixed camera video analytic to detect ground threats or it's a radar to detect air threats like drones. They provide the intruder coordinates to RSA, which then showcases it on a map in Security Center. Then within the Security Center platform, Omnicast Genetec's VMS receives the intrusion location data and then controls the Bosch MIG cameras to follow and then track the intruder. So now here, the RSA feature that enables the automatic camera handover will allow us to immediately switch to the next camera in the area that has the clearest view of the target. So this seamless ability to switch between cameras is largely due to the strong integration partnership we actually have with Bosch. And then finally, in real time, the video footages together with the map view of the target is showcased as a single view on the security desk. So the operator, they can have full and continuous view of what is actually happening in their apron area. So the solution that we have together in terms of functionality is really like no other in the industry. Now, Martin, yeah. I'll hand this over to you now to go through the video.
Okay, thank you. So this is an approach how to do it in a smarter way where we are leveraging technology to monitor the security fence. So what you see here, this green canvas is basically an area where we are supervising the fence. And once something is approaching the fence, you see that this area is turning red. Yeah. So
two thermal cameras.
Yeah, so you see here, here you see some thermal cameras which are monitoring the fence line. And as soon as something approaches the fence line, there will be a trigger into the control room. Cheryl, is the video running?
And video analytics continuously scans the area for moving objects. One moving camera is securing another part of the premises.
So as soon as an object is being detected, you see that the MIG camera is actually being controlled, and it is trying to find its way to the object that is moving along the fence line, and this video footage is automatically shown into the control room.
Sorry about that. Let me.
In this example, Avert Analytics continuously scans the area for moving objects. One moving camera is securing another part of the premises. The real-time field of view of the cameras is visualized in blue and green. Video Analytics detects a moving object, and an alarm is triggered. The moving object is classified as a person, and the location, object speed, and trajectory is visualized. The moving camera is triggered at the same time, and it steers towards the moving object and starts following the person with intelligent tracking. A new video window shows the person walking towards the second camera. As soon as the person passes the second camera, the system does an automatic handover and shows the video image of the second camera. Now you can track moving objects over multiple cameras in real time.
Okay. Yeah, the audio, I think, explained what the use case is about. So we have the cameras that are automatically following an object when it is approaching the fence, and there is also handover between the different cameras. On the map, the operator can actually see where is the object moving, so that gives a lot of spatial awareness to the operator. Where is the scene actually taking place? So he also knows where to send a security guard, and he can also follow the scene while intervention is taking place. So this was a scenario where you see this handled with an intrusion over ground. But as I mentioned before, it can also be that we have an intrusion in the air by a drone, and also there we have video footage, and of course we have a geospatial awareness that we need for the operator. So Nicholas, could you maybe show how such a use case looks like?
Yeah, thank you, Martin. Can you all see my screen?
Yes.
Okay, perfect.
Yes.
So I'm going to explain the setup that we have here. So again, we are located in close to the Montreal airport. So I created 2 zones. So if I zoom in a bit, you will see a zone that it's not actually filled with green, but it's surrounded by a green line. I call that zone the buffer zone. So it's not the airport zone, but it's a zone that we want to watch because we have some forest, we have some playgrounds. So if anyone actually plays with a drone or starts flying a drone here, I want to be notified because it's close to the airport. And the second zone, of course, is the airport zone. So as you can see here, we have the zone covering all the airports. And what you see in blue are actually live planes moving now in Montreal. So it's 4:30 a.m. So we have some planes in the airports. And I have 2 cameras here that will be used for this scenario in order to visualize what the intrusion detected by our system. So I'm going to simulate now a drone arriving at the buffer zone. So what you see now is the drone detected. So you see that the buffer zone turned red. So it's not yet an intrusion for the airport, but still I want to watch it because it's an unknown flying vehicle, and I want to track it. So in order to do that, the operator needs to click on the target. So on the left, you will see all the information linked with the target. So that's a drone because we see that we have a dedicated type icon showing that it's a flying object. We have the speed, the direction, the altitude, and we see the drone is active. So I'm going to zoom in a bit so we can see the path a bit more. It's going to be more precise. So the drone is now gonna fly, and it's approaching the PTZ of the airport. And what you will see is that when the drone enters the field of view of the first camera, the system will automatically position the PTZ camera in order to track the zone. the drone, sorry. So the drone will fly and is now approaching the airport zone. And now the drone will enter the airport zone. And what you see now is that the airport zone turned red because now we have an intrusion in the airport space area. And we want to make sure that actually the drone is taken care of. So I will, sorry, select the drone again. And the drone is now approaching the second camera. And what you will see is that again, the system changed the camera automatically. I didn't touch anything. We just computed that the best camera to see the drone is the other one that I have here. And now we are tracking the drone and we can handle the situation. We can send some patrol. We can, if we have a system to detect the pilot, we can send a patrol to the pilots here located in this field. So that allows you to monitor the situation and take actions. Back to you.
Thanks, Nico. All right. So that was RSA, and also when we talk about RSA, there's really 5 key features that makes it stand out. First, as you saw in the demo, its ability to target track on a map and manage zones within the restricted area by having the ability to arm, disarm, or even set these zones to maintenance modes to prevent false alarms. Secondly, as I mentioned just now, is its ability to automatically hand over the camera that's tracking the moving target seamlessly, so the operator can continuously have eyes on the target. The third ability is the automatic target fusion. So what this means is that when 2 systems detect an intrusion, instead of recognizing it as one of the same target, it detects and alerts the operator as 2 different targets. Whereas within RSA, we're able to eliminate the noise and recognize that it's the same and only notify the system of that one intrusion. The fourth feature is the investigation task, where the operator can easily pull video footages and play back what happened for investigations, and on both a map view and a video view of the incident can be showcased. And then last but not least, RSA supports many different types of technologies. Here's just a quick list of our existing partners who we have direct integration with. So from fence sensors to radars to LiDARs to video analytics. So if you need more information on our full list of integrations and device, feel free to reach out to us and we will have that sent over to you. And that's basically this part. Now that we've actually seen how we can assist airports in managing different types of intrusions, let's move on to the next section of our presentation on detecting speeding vehicles in the apron. I'll hand you over to Martin to start us off. Martin?
Okay, thank you, Cheryl. So indeed, this is the next use case. And very interesting, this actually evolved when talking to airports, showing what we can all do with the MIG camera, especially on airside. We actually talked to them about recording the landing of the aircraft and then following the aircraft across the taxiway. And then actually they came up with the next use case and they said, we always have issues with speeding apron vehicles. And we would like to have a recorded evidence that we can show to a service handler that his vehicles are actually speeding on the airside, which is a safety hazard to us. So also there we can apply video technology to help out, because as you can see on the next slide, if you look at the camera, usually what people are aware of that it is showing a video image, which is the most obvious. But actually a modern camera and a Bosch camera to extent is actually also analyzing the video footage, and it's generating a lot of data out of that. It's recognizing people from bikes from cars, trucks, boats. It's recognizing colors, it is recognizing trajectories, and it is also measuring speed. So there is a lot of data that is actually generated by a camera next to the video stream, and that is captured in what we call a metadata stream. And this metadata stream, we can feed that directly into the security platform of Genetec, and this speed information can actually be used to trigger if a vehicle is speeding, and also to make a recording of that, so it can be retrieved afterwards as an evidence. Cheryl, maybe you can show a bit how that looks like in Genetec.
Yeah, sure. So another way for us to detect the airside vehicle speeding would be leveraging the ADS-B. So in this case, we can set a speed threshold for vehicles in a specific zone. We can then create alerts when that speeding vehicle is detected. And then within the Apron movement tracking module, a video with the speed overlay of the vehicle can be showcased. So this will allow the operator to take a snapshot of the incident and then save it for reporting purposes later. So I'm going to hand you over to Nicolas to give you a glimpse of how this actually looks like on our Security Center platform. Nico, over to you.
Thank you, Cheryl. I will share the screen now. Okay. So what you see here is the closer look at the taxiway at the Montreal airport. And I'm gonna now simulate a car that's speeding on the taxiway. So we have a car here, and you see now the car is approaching. Where is my car? Here, sorry. So I click on the car, and automatically the system will now be able to detect that we have a speeding vehicles, because we have the speed recorded, and we can automate the recording of the car by the camera, actually with the best camera that can see the car, in order to investigate the situation later. So back to you, Cheryl.
Thanks, Nico. All right. Okay, so before we go into the next section, I just wanted to hand you over to Constant to take you through some recommendations in terms of camera for this type of use case. Constant?
Thank you, Cheryl. Yes, when you want to detect the speed of vehicles moving on the airside, you can make use of the intelligent video analytics from Bosch cameras that is available in the Dinion and FlexiDome 7 and 8000 series cameras. This camera, once it's calibrated, will give you speed readings of the vehicles that the camera detects moving on the scene. And this information is fed into the Genetec system, as Martin already explained, and is triggering a recording in the video management system to have recordings of speed incidents. So it's basically the 7000 and the 8000 series which have the analytics on board for doing this type of detection. Back to you, Cheryl.
Thanks, Constant. I see some audiences raising their hands to ask questions. Feel free to type your question in the chat, and our moderators will get back to you as soon as possible. Thanks. If not, we'll address it at the end during our Q&A. All right, now into our last section on airport and apron monitoring. I'll hand you over to Martin to start us off with the scenario. Martin.
Okay. Yeah, thank you, Cheryl. So as you saw, we have now basically what we call a video airside solution suite. So we looked at recordings of landing and departing aircrafts. We look at how to secure the perimeter fence for intrusion over land and through air. We also looked at monitoring vehicles moving on the airside and detecting safety hazards because they are speeding. And basically, to overarch it all and bring it all together, you could digitalize the whole airside by basically monitoring it and recording it. As we know, the airside, it's a huge area, a lot of activity is happening. So making recordings of that simply makes sense to also have basically every incident on camera. And also, if you want to optimize processes, that you can draw the data out of this, out of these recordings, and try to see how you can optimize. Also, we also saw it in the questionnaire in the beginning. So low visibility is one of the big issues that you have also on the airside. So a camera technology can definitely provide you an extra set of eyes, which even has better performance to have a look when the environment is really dark and the visibility is really a challenge to operators. So Cheryl, maybe you can show us how this looks like from Genetec perspective.
Sure thing. So this visual here, as you see, depicts perfectly the typical Security Center for Airports view in the Security Operations Center, with the flight task, the map view, as well as a video surveillance feed of the airport area, all on one single pane of glass, so through our unified platform. In terms of how it works, based on the situation that Martin explained in airports, how can we actually help airports gain a stronger visibility and a better situational awareness of the aircraft surroundings, whether it's on the runway, whether it's on the taxiway, or whether it's on the aircraft stand. So we together with Bosch worked on a solution on deploying multiple cameras along the area of interest to be monitored, and then voila, basically glue or stitch the images together to obtain a panoramic view of the entire area. Now, the security operator, they can use the created panoramic views video stream to monitor the operations and respond to incidents with greater visibility and control. And one thing to keep in mind is that the cameras must be of high quality and accuracy to be able to reproduce the scene correctly and allow for a clean stitching of the images to actually happen. So Constant, finally, I'll pass it to you to take us through some of those requirements.
Okay, sure, Cheryl. So basically, when you stitch, you make use of cameras with a high resolution, so 5, 8, or 12 megapixel, and you make use of the multiple stream capabilities of these cameras. So for the stitching, you take a full HD stream from each of these cameras, and these are stitched together in real time to provide the overview image. And once you want to have a more detailed look at a specific area of interest in that overview image, you click on the image, and the high resolution stream from the camera that is covering this part of the image will be shown and will be showing more detail. The cameras that you would normally use for this are Dinion 8000 level cameras, which are 5 to 12 megapixel and capable of feeding the stitching system to provide the overview. Back to you, Cheryl.
Thank you, Constant. So before we head over to the Q&A, I just wanted to recap the 4 topics that we covered today. So we went through our solution to visually track aircraft during taxi takeoffs and landings. We then went into our ability to provide a 360 perimeter protection for different types of intrusions, such as drones. We also covered some ways of detecting speeding vehicles in the apron, both with video analytics and also by leveraging the ADS-B. And then finally, we showcased how we can increase visibility of the security operator by stitching video feeds together to provide a complete airside scene overview. I really hope that the session was interesting for you. And if you have any projects or opportunities coming up that you think this solution might be well suited for, don't hesitate to reach out to us for more information. You can get in touch with David Leno, who's the airport practice lead in Genetec. You might have probably spoken to him in the chat already. Or Richard and Jeremy in Bosch, who are our integration partner managers in the different regions. So Jeremy for the APAC region and Richard for EMEA. And I wanted to thank you all again for joining us. And so let's proceed with the questions that are going on in the chat. I know that there were a lot. I'll invite David if he can bring them up to the audience.
Hello, Cheryl. Good day, everybody. I hope you can hear me well.
Yes.
Good. So, well, first of all, thanks a ton all for the contribution in the chat. That was a very, very active session. Some of you were really, really interested, and I guess already quite deep in the topic. So there were many questions, but there were two main subjects that kept coming back. One around the tracking of the different objects on the map, and the other one that had to do with drones, especially drone suppression. So I want to first comment back on the ability to show objects on the map, so objects being aircraft or drones for flying objects or other types of vehicle which are on the ground. So we did guide you through a number of different modules, some of them really for operation to track aircraft, for example, the other ones for security to detect intrusions. Now, reality is those different modules or application, they really get together and stick together in the platform. So we make it really transparent for you to see objects of different natures for different purposes. And you will see really on the same map all those types of objects. And to capture those objects, we may use different methods. So practically there are two types of objects or targets. There are those targets which communicate their positions. So typically aircrafts, which all carry by regulation transponder and use ADS-B, or vehicle on the ground, so your own vehicle, which you can also equip with transponders. In that case, we use simply an ADS-B antenna, which really is just a couple of $1,000, which you can mount on the airport premises. And from that, we will be able to receive in real time the locations of all those cooperative assets. And we will receive those with additional information, such as maybe the aircraft registration numbers or the ID of the vehicle. For the non-cooperative targets, so vehicles that should be there but don't have a transponder, or for all things creating intrusions, so drones, people walking, vehicles, etc., we use other technologies. So the prime one really is radar technology, and with the radar we will capture the position of the object and will display it on the map as well. Most sensors also do have the capability to classify objects. So we will receive with the target position classification, which could be a pedestrian or a vehicle or drones, etc. And that will be also used in the interface. As you've seen, we have different icons. So you will see a drone icon or a vehicle icon, etc. And having both at the same time, so cooperative and non-cooperative, really helps you understanding what's happening out there. The other subject was around drone suppression that came a few times. So what you've seen is really good at showing you the location of the drones, ideally before they enter the area you manage or on the premises itself. The question of suppression, which essentially means trying to send back the drone or destroy the drone, is a bit of a touchy thing, because it has to do with local regulations. So in most countries or regions, you will have the local authorities who may not allow you to suppress drones, simply because it poses a number of risks, safety risks. So first of all, crashing a drone on the ground may crash the drone on people or assets. Also, if you use radio frequency to jam the signal, you may interfere with important radio signals, especially in an airport context. So it's not something that is easily implemented, and most of the time this is done in coordination with the law enforcement or military interventions. And what we see is the cooperation between airports or site owners and the authorities to do so. I'd really like to invite you maybe to listen to a webinar we had on drones just last week. So a Genetec webinar where we discussed with the Johan Cruyff Stadium in Amsterdam. So we shared quite some insights on how this can be done. So yes, suppression can be done. There are tools for that. We could also as well integrate and automate them in the system, but really right now it's the regulation that is blocking a little bit the operations. Yes, so those were the two main topics, and for a few more comments, I also like to point out to the choice of cameras. So it was stated a few times, but I really want to insist on that. It's one thing to capture the position of the objects and show them on the map. It's something else to send the camera to the object and track the object. And that's a very fine art to be able to manage that. And you need really a camera that that can be controlled in such a refined way and move in such a refined way that the object stays in the picture. And I can't insist enough on the performance of the MIC camera here. I mean, we really truly encourage you to look at that specific camera if you want to do such things. And well, I mean, you can always try to gain experience with other type of stuff, but yeah, it's a pretty complex exercise. So yeah, I think that covers most of it. I'm just quickly reading through the latest questions. Oh yeah, and a good question here about integrating flight data. So I guess capturing an aircraft position and then do augmented reality type of application. So display the aircraft registration on inside the video feed itself. So yeah, so that's something we're actually looking at. So that's possible. Quite frankly, we've been experimenting a bit with that. Now it's just a question of productization. We will need the actual engagement to productize it. But yes, that's it's going to be there eventually. That's pretty sure. Yeah, and then yeah, a number of other questions which we will respond just after that. But again, thanks a ton everybody for the engagement. That was really intense. So thank you so much for that, and thanks to all the panelists for the contribution. Back to you, Cheryl.
Thank you, David. Well, we will be staying on if you have any additional questions for us, but feel free to drop off at any time. And thank you again for joining us.